All right, so today we are going to continue talking about normal distribution, the normal curve. And what we did last time was we used that 68, 95, 99.7 rule to talk about very exact standardized values. Okay. Now remember, standardized value is called a z-score, and so all these numbers on the chart are one standard deviation above the mean, 2 standard deviations above the mean, 3 standard deviations above the mean, 1 below, 2 below, 3 below. Okay, but again, another name, instead of always saying standard deviations are above or below the mean, we call them standardized values or z-scores. Okay, these are the same terms, just different ways to talk about it. Okay, now when you're using that 68, 95, 99.7 rule, that again speaks specifically to a z-score of 1, 2, 3, or -1, -2, -3. Okay, again, very specific examples. What we're going to talk about today is what happens when you are not an exact standard deviation away, but what about -1.25 standard deviations away, or 1.25 standard deviations away, or 2.5, or -1.98? What happens when the numbers aren't as clear as 0, 1, 2, 3, or -1, -2, -3? That's what we're going to look at today. So hopefully you have printed out that z-score table and you've looked at watching the video on how to use that and how to read that, because we are going to be using it today. If not, I would just hit pause and make sure you watch that first, and then obviously make sure you print off your standardized table so you can start using that during the notes and the assignments. So when you're reading the standardized table, it is used to find the area to the left of the corresponding standardized value. And I underline, bold, circle, star, highlight, whatever you need to do the word left, because it measures everything below the value you're looking for. Okay? So the table entry for z, again, speaking of that standardized table, you need to have that out right now. If you don't, then you need to pause the video to go get it. But for that table entry for z, it is always the area that is to the left of the curve. That is what that table approximates. And so when you look at that table, you just see a bunch of random decimals. Those decimals are the percentiles that we've been talking about throughout Chapter 4. But what this chart does is it provides us, and I have one brought up here. So what this chart does is it provides us with an opportunity to say that if you score, well, look at 0, 0. If you're at the mean, remember that's 50% of the data. Let's look at 1.0. Notice that that's 84% like we did in our notes. Again, those are all approximations. But what about 0.61? That's what we're going to be talking about today. That looks like it's about 73% will score less than 0.61. Okay? So again, let's just look at learning how to read and interpret these tables. It says find the proportions of observations from the standard normal distribution that are less than -1.25. Okay, so on my table, I would find -1.2, and then I would go to the 5/100ths column, and because it was less than, then my answer is about 10.56%. Okay, so we would expect, and again, this is true for every normal distribution. If -1.25 is about right here, we would expect 10.5% to score below that level. Okay, which means we could look the other way at it. We would expect about 89.5% to score above that level. And so that's why you need to pay close attention to the wording of what you're finding. So in the first one, it specifically said, find the proportions of observations that are less than -1.25 standard deviations. Now we're looking at greater than 0.81 standard deviations. Okay, so again, I go to my my standardized table. I find 0.8, I find 1 in the 100th spot, and I get 79.103%. But again, what that means is everything below this is about 79.103%, which means the actual answer I'm looking for is everything greater than it, which would end up being about 20.897%. We could probably just call that 20.9% as your answer. So if it's greater than, you have to do 1 minus your 79.103 to come up with your percentage there. If it's less than, then you can just take it straight from the table. If it's greater than, then you have to subtract. So if we continue with different types of examples in this standard normal distribution, we had talked about if they give you a z-score that is less than, if they are asking you to find the percentage of when the z-score is greater than. Now let's look at in between. And just for simplicity, I'll use the last two examples that we talked about, where we found in the first one, we found what the z-score would, or what the percentile would be for somebody that was a z-score less than 0.81, or then for somebody greater than. But what if we did in between? Okay, and so think about this math here, and I give you a visual reference as well. If I wanted to find the proportion or the percentile of observations that occur between a z-score of negative 1.25 and a z-score of 0.81, I would take my two z-scores, starting with the bigger one. Remember, 0.81 would be bigger than any negative number, so bigger than negative 0.125, and subtract them off. Okay? Again, from a visual perspective, the reason why I'm subtracting them is because I'm looking for this range of values right here. Again, that is greater than, so if this is 0.81 here, I'm looking for greater than 0.81, but then oops, nope, that was negative 1.25. I'm sorry, greater than negative 1.25, but then less than 0.81. And so I'm finding just this area here of percent of observations. And so again, visually, less than 0.81 would be everything here, but then I need to cut off this last chunk because we're cutting it off at negative 1.25. And so I subtract those two together, and so 68.54% of the observations would be between 0.181 and negative 0.125. And so again, each example that we're talking about has a slightly different twist to it. And so if it's between two values, then it might help. When people come in for help, I often draw quick sketches of this because it might help visually to understand that you need to subtract those two values from each other. Now let's look in the other direction. It says find the z-score that corresponds to the 90th percentile of the standard normal curve. So in this case, you are going by the percentile. And so now we're really going to have to dig through our table. And again, your chart is read as what's less than. And so when it says 90th percentile, we want to find this z-score right here, that 90% of the data would fall equal to or less than from there. Okay, so again, we're working backwards here. We have to dig through our chart and we have to find what z-score corresponds. And so there's going to be two that you're going to end up between. Okay, and so what I should do here is if I look, let's see here, looks like right here. You see at this number here, 0.89973, and then 0.90147, we need to figure out which number is closer to a z-score, or to the 90th percentile. Obviously, they're both very close, and so if you said either of these z-scores, you would be, you'd be in the right spot, but we can be even a little bit more exact if we find the closest one. Okay, so when I look at this number, And if you were to use a calculator, and what you could do is you could do 90, whoops, 90 minus 89.973 if I just kind of move that decimal over. And then comparatively, you could do 90.147 minus 90. And what you would want to do is you'd want to find the number with the smallest distance between. Okay, this one's pretty easy. It looks like it has a distance of about 147 thousandths. But this one's even closer. It has a distance of just 27 thousandths. Okay, and so the z-score that would correspond, the most accurate z-score that would correspond would be the one that it corresponds to the 0.89973, which if I look at what row and column that's in, that is a z-score of about 1.2, or not about, that is a z-score of 1.28. And that's as close as we can get. Okay, but again, if you put 1.29, yes, you're in the right area. If it's on Schoology, it's going to mark it wrong because it doesn't accept a range. It just accepts one answer. If it were your test, I'd probably give you half credit because yes, 1.29 is close. 1.28 is closer. Okay, so we can be even more accurate with that. And so anytime it gives you the percentile, then you're working backwards in the table. You're going to have to dig through that table, and there's always going to be two numbers to kind of pick between, and then you have to figure out from there which number is actually closer to find the z-score. Okay. On the other hand, one last one here. It says find the z-score that corresponds to 30% of all observations that are greater than z. Okay. So if I picture this on my chart, what we are trying to picture is 30% greater than, which we need to then realize means 70% is less than, because it's the 70% number that we are going to look for in our standardized table. Okay, so what I would do is I would challenge you to hit pause and find this on your own, and then I'm going to go through it myself. So then hit play, and let's make sure we end up with the same number. Okay, but because it was greater than z, I actually needed to think of it in terms of, well, if 30% of the scores are greater than, that means 70% of the scores are less than. This is the number I'm looking for in my table. Okay, so go ahead and hit pause so that you can find that yourself, and then hit play so that you can see what we end up with. So in my table, again, I'm working backwards, and so I see like right here I'm at the 5% mark, which isn't anywhere close, close to where I want to be. I'm looking for 70, okay? Looks like I'm getting closer right here. And okay, right there, right in between those two values, 0.69847 and then 70 or 0.70194. And so it looks like this is 194 thousandths away from or no, that's more than thousandths in this case. What would that be? 100 thousandths away. And this one is a little bit closer because it's only, let's see, 153, so 153 thousandths away. Okay? And so again, yes, 0.53 would be close, but 0.52 would be even just a little bit closer. And so that is your z-score. That corresponds to 30% of all observations that are greater than z. Okay? Remember, this table and this chart always represent the area to the left of the z-score, or that's less than the z-score. So anytime you have a greater than scenario, that's where you have to actually think of it. You have to subtract off the difference there. Okay? So homework aligned with this is 4.6. What 4.6 is really just practicing the table, practicing using the table, practicing interpreting the questions. When should we be subtracting? When should we not? How do we do the between problems? Okay? Your last set of notes that we'll do together, we'll get into more of an application. So make sure you really understand 4.6 before you move on.